Okay, for the second part of the rational expression, Algebra 2 review, we are asked to find the inverse function for these particular functions. So for letter A, we have that f of x is 3x to the 8th, as long as x is negative. Okay, and so to find the inverse, there's some steps you need to follow. First up, you have to replace f of x with y, the variable y, the same thing, right? And then I'm going to have you, let's do this, it doesn't matter, steps 2 and 3 can be interchanged. So in step 2 we are going to interchange, we're going to switch x and y, and we're going to solve for y. And the last step is then go back to the other notation and replace y, but not with f of x, with the symbol f inverse of x. Okay, those are the steps to find the inverse. So first thing, I have to call f of x y. Second thing, I have to replace x and y, or interchange them, sorry. Second step done. Third step, I need to solve for y. Okay, there's a certain order in how I have to go about that. Okay, first I need to divide by 3. So I have that y to the 8th is x over 3. And then we take the 8th root to undo the fact that it's to the 8th. And it gives us that y is the 8th root of x over 3. Okay, you done it. Step 3 is done. And finally, we'll say that the inverse function is the 8th root of x over 3. Okay, great. Part B, we have g of x is 3/2 of x cubed plus 4. Let's call that y. That's a 4. Let's switch the x and y's. And let's solve for y. Subtract the 4 to give you x minus 4 of y cubed. Let's multiply by 2/3 to do it all at one time. Now we cancel the 3 and cancel the 2. So we'd have y cubed is 2/3 of the quantity x minus 4. Very important you put the parentheses around that. And just take the cube root. And we're done. We'll have y is the cubed root of 2/3 of x minus 4. And we just call that f inverse. And I guess you could possibly distribute the 2/3 across, but that's good enough. Alright, great. Now let's go on to number 5. How do I do that? There's something down here that's supposed to let me. My tools aren't coming up. Escape out of here. Ay, ay, ay. thing to work. Okay, it froze up for a second there, but it looks like it's good. That's not exactly what I had, but okay. I guess I was writing too fast. 1 second. Ay, ay, ay. We're going to come up with a third plan here. 2/3 x minus 4. That is what f inverse of x is. The cubed root of 2/3 of x minus 4. I don't know why I think the cube disappeared on me. Okay, there we go. Alright, then we have question number 5. Let's try to finish this recording out before we try the third kind of software to help us do our recording. Let's just blow this up. I don't want to go to full screen. Okay. Jeez. Okay. Number 5. State the graph the function, state the domain and the range. Okay, so these are some alterations on your radical functions. And so, if you take a radical function and multiply it by 2/3 square root of x, which we know looks like that, what does multiplying it by 2/3 do? Well, 2/3 being less than 1, what that causes a vertical shrink. It's not as high as it used to be. For every x that we plug in, times it by 2/3 means it's 66% as high as it used to be. And so we don't have to be exact. We can just sort of draw a graph that will be compressed or shrunken vertically. Just picture yourself as pushing in from the top and the bottom, and it just looks like that. That's good enough. We'll call that 2/3 square root of x. What's the domain? Well, the domain would be all x's greater than 0. It's the same domain as the root x function. X is greater than or equal to 0. Okay. Now for the range, your possible y values, what you have for that is the same range as the root function. We get all y's greater than or equal to 0. That's the inequality way to say it. There's the interval way to say it as well. This is 0 to infinity, and this is also 0 to infinity, but since we can include 0, we put a square bracket. This thing disappeared on me. Jeez. I don't know. Okay. Then we have letter B. 3/5 of x plus 4 underneath a root minus 1. And so with that one, we're doing some shifting left and right, left or right, up or down of the root function. Okay, the minus 1 is a shift down 1 unit. the plus 4 would represent a shift to the left 4, not right. When it's happening with x, it's counterintuitive to what you would think. So we shift left 4 units. And the 3/5 does the same thing as the 2/3 did, because it is less than 1. It will vertically compress. Okay, I would just draw them on the same axis. Here's your generic root x function, and then we go to do those alterations. We're going to shift down 1 unit and left 4 units. The only identifiable point is this origin. It goes down 1 and over 4. So it moves from the origin to the point -4, 1, -1, -4, -1. Okay, now when it comes time to show the vertical compression, we can sort of exaggerate it like we did up here, and so we'll just say that instead of having this kind of a bend, we have a less severe bend. And when x is 0, where are we at? When x is 0, we're talking about 3/5 take away 1, 3/5 times 2, which is 6/5. Take away 1, which is 1/5, just barely above the x-axis here. I'll make sure I go through this point somewhere there. Ooh, it's bad. Alright, so we bend. Just a more severe bend, or less severe bend than before. And that's the new function. 3/5 the square root of x plus 4 minus the 1. Okay, great. What about the domain and the range? Well, how did you affect the domain and range for root x? You shifted in x. What you did is you shifted to the left 4 units. So the O domain of 0 to infinity is now going to be -4 to infinity. And then with the range, the old range was y is bigger than 0. You shifted down by 1. So you'll have y is bigger than or equal to a -1. And so in interval notation, that is -1 to infinity. Square bracket when you can equal, parentheses when you can't. Alright, great. And finally, the last one. We have -1/2 times the cubed root of x minus 2, and then 2 is added to that. The plus 2 is a shift up, 2. The minus 2 underneath is a shift right, 2 units. The -1 does 2 things. The fact that it's negative means it's an x-axis flip, rotation, reflection. Sorry, reflection is a better word to use. Oh my God. I don't know what happened. Oh boy. I guess PowerPoint wasn't the right software to use either. Paint crashed, now PowerPoint is crashing. You have to come up with a plan C. Okay, I don't quite know what happened here, but I think. Okay, there we go. Sorry about that. So, where were we? Oh, okay. So the x-axis, I was just trying to do an erasure. Simple thing. And it's not letting me do it. I don't know what's going on. It's not a heat on this. Come on. Okay, so we have an x-axis reflection is what I want to. I just want to get through this. Come on already. I put the word reflection. I don't know. Stuff keeps disappearing on me. Anyway, yeah. And the half does the same kind of thing before a vertical compression. Okay, so we have to perform all those at the same time. Yeah. So it's not a square root anymore. It's a cube root. Different function, a different kind of a graph. Y equals the cube root of x. Okay. Boy, just not cooperating. Okay. Y equals the cube root of x looks like this. Well, it's a mirror image, so whatever's in that first quadrant is reflected down and in the third quadrant. So it doesn't look exactly like that, but hopefully you get the point. So we have to do some shifting and reflecting. So okay, so we need to do the reflection first. It's in the order of operations there. So we reflect. So it would look something like that. That's the reflection. And now we do our compression and our shifting. Okay, we're going to shift up to, we're going to shift right to, and we're going to compress. So take the blue reflection, shift it up to, shift it right to, only identifiable point is the origin, and just do a compression where it's some kind of a noticeably different looking, where it's been compressed in with so it has a less severe bend. Something like that. Okay. This thing's going haywire. Okay. Alright. Finally, we are done with that one. And let's just go to the last page, which is solving equations. Okay, here we go. Solve these 4 equations. Solve them for x. Okay, let's just make it through this. Alright, so first up, the 5th root of 4x minus 8 is equal to 2. Well, we have to solve for x. We have to undo the things that are being done to x in a certain kind of order. And so, first off, we'll undo the 5th root by raising both sides to the 5th power. And so, we'll end up with 4x minus 8 being equal to 32, 2 to the 5th. And then we're on the linear level. We add 8. We get 4x is 40. We divide by 4. And we get that x is 10. Okay, great. Next up, we have 60 minus 1 over 20, x plus 75 to the 3/2 power equals to 10. Okay, we first need to subtract the 60. And so that leaves us just with the negative 1 over 20, x plus 75 to the 3/2 power, and it's going to be equal to a negative 50 when we subtract 60 over. Times by 20, negative, we'll have x plus 75 to the 3/2 power equals a negative 50 times a negative 20. Okay, and that is 1,000. Positive. All right. Next up, raised to the 2/3 power, the reciprocal power. So that would take care of the exponent. And we need to do it to 1,000, 2/3, 1,000 to the 2/3. That is what x plus 75 is. How do you do 1,000 to the 2/3? Well, you think about 1,000 as 10 cubed, and then that's raised to the 2/3 power, and you get to multiply those exponents together, to a power, and they cancel each other out. So we get 10 squared, which is 100. That's what x plus 75 is. And we just subtract the 75 over, and we get that x is 25. Okay, let's finish this off. Letter C. No more room on that side. Okay. I don't know what just happened there, but okay. So this is letter A, and this is letter B. And then we'll move over here and do letter C. What are we looking at? X plus 1 is equal to the root of 19 minus x. Okay, so we have to square both sides. Undo the root. We can't shift these x's to the same side yet. And so we'll have x plus 1 squared is 19 minus x. But don't think you can just square the x, square the 1. There's a middle term, which would be 2x. It'll be a 1x and a 1x. Okay. And then we have to set it equal to 0. Set it equal to 0 by subtracting the 19 over, adding the x over. We'll have I think it's about to crash. Let me pause again. Okay, sorry about that. Let's just finish this off. We have subtract the 19 over, add the x over. We'll have x squared plus 3x minus 18 equals to 0. We have to factor. So either we get x plus a 6, x minus a 3. Either x is a negative 6 or x is a 3. You have to make sure that both of them are allowed. If we put a negative 6 in, it's okay. It doesn't give us a negative underneath the square root. And we put a 3 in, that's okay. It doesn't give us a negative under the square root. Doing great. Okay, last one. Letter D. Four root x minus 2 is equal to the root of 5 minus x. Alright, do this one and we are done. Okay, and x is under that root. Okay. Yeah, we're going to have to square both sides. And then I think a square again. That's okay though. So we're going to square both sides. And the way we go about doing that, oh boy, it's just terrible. Okay, square both sides. Alright, we square the right-hand side. Of course, we just get 5 minus x. Let's think about the left-hand side. 4 root x minus 2 times 4 root x minus 2. You'll get 16x. Root x and root x is x. You'll get minus 8 root x minus 8 root x. So minus 16 root x. And then plus a 4. So nothing you could do to put those together. Isolate the root x term by doing what? Let's put it over here and then move these guys over to the other side. So we'll have a 16x plus a x is 17x. A 4 minus a 5 is a negative 1. And that's equal to the positive 16 root x when we move it to the other side. And now we square again. Yuck. Oh, 16 squared. 256. 256. Okay, so we have 256x. Here we square, boy, 17 squared. Don't know that one. These pieces are missing. 11, 17, 289. 289x squared minus a 17x minus 7x, so minus a 34x plus a 1. Wow. Alright, almost done. 289x squared. We need to subtract this over. Is that 300? No, 8. That's minus 290 x plus a 1 equals to 0. That might be factorable. Wow. Yeah. 289x and x, 1 and 1, minus and minus equals to 0. Wow. So x is either 1 or 1 over 289. Ay, ay, ay. Okay, let's check our answers.